Okay, so 2012 AP Calculus AB free response questions. Number 6. For 0 less than or equal to t, 0 less than or equal to t less than or equal to 12, the particle moves along the x-axis. The velocity of the particle of time t is given by vt equals cosine pi over 6t. Particle is positive at x equals -2 at time equals 0. Okay, so for part A, it says for 0 less than or equal to t less than or equal to 12, when is the particle moving to the left? So for this, I drew a graph of what the equation is. So I have it starting at 0 up here because it's a cosine graph. And here's the equation. So it'll start here, it'll go down like this, and come back up. So, for the period, it'll be it'll be 2 pi over b, and this b is going to be pi over 6, so that makes the period 12. So right here it'll be 12, and here will be 0. So halfway in between that will be 6, and that'll be this middle point, this low point. So you go halfway in between 0 and 6, and you'll get 3, and halfway between 6 and 12, and you'll get 9. So we can tell that the particle is moving to the left because the velocity is negative from 3 to 9. So it is moving to the left from 3 to 9. And that is the answer to B, or A. Then for part B, it's asking us to write but do not evaluate an integral expression that gives the total distance traveled by the particle from time t equals 0 to time t equals 6. So what I did was I just created an integral from 0 to 6, and since it's total time, I did absolute value of the equation, which is cosine pi over 6 times t, then dt. And that's all you have to do for 6, or B. And then the next one was C, and it asks us to find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time t equals 4? Explain your reasoning. So for this, I just wrote down what the initial velocity equation is, and that would just be our cosine equation. And then all we have to do is derive that to get the acceleration. So we have negative pi over 6 sine pi over 6t, and that is our derivative. So we'll put in 4 for t. So there we go, and you can simplify this down a little bit. You can make it better. So it will be in the end negative pi over 6, 2 pi, or sine 2 pi over 3, because you have your t replaced as a 4. It'll be 4 pi over 6, and you can simplify that down to 2 pi over 3. So that is the acceleration, and we can find that to be negative. So what I did to find out that was negative was I did a circle for the unit circle, and then over here I put it at 2/3, or about 2/3, 2 pi over 3. And for sine, this would be negative, or this would be positive. But since you have a negative pi over 6 multiplying that, this whole acceleration would be negative at 4. So we would also do this with the velocity to see if it is increasing or not. So if we put 4 in, it will come out to be cosine 2 pi over 3, and that will be negative. So this is negative, and since they're both negative, that means that they're both increasing. So yeah, since they're both negative, that means they're both increasing.
The speed is increasing.
Yeah, the speed is increasing. So for the final part, D, any more room, so I'll go up here. For D, it asks us to find the position of the particle at t equals 4. So what I did for this is I did U substitution. So I started off like this, 0 to 4. And I took this value, or this part right here, and used that as my U. So I derive that. And that would be pi over 6. And I need to get dx by itself, so I would have 6 over pi, because you need to multiply dx to the other side and then divide by pi over 6. So you get 6 over pi du. And I would bring that back in, but before we do that, we need to find the bounds for the integral. And you put 0 in for t, so that would be 0, 4 into t, and you'd get 2 over 3. So the upper bound is going to be 2 pi over 3. The lower bound will be 0. At this point, I'm going to put a negative 2 out front, because you start at negative 2. That's where you speak it in the graph, and that's where the function begins. So I put that out front. I'll also put, so negative 2 plus, I'll also put the 6 over pi out front to make it a little bit easier. And right here it'll just be cosine u du. So we need to integrate that. And to integrate that, we would just get 2 plus 6 over pi sine u. So, and this would be 0 to pi over 3. So from here, we would just have negative 2 plus, and we would have this in parentheses. So it's going to be 6 over pi sine 2 pi over 3 minus 6 pi, oops, doesn't need to be there, 6 pi sine 0. So we have that. And using the unit circle again, I just found the values of what sine 2 pi over 3 would be and what sine 0 would be. And it would come out to be negative 2 plus 6 pi. And this would be square root 3 over 2. And then minus over here, this would just be 0, because you get 0 from that, and then you just multiply right there. So it would just be 0. And overall, what I got was negative 2 plus 3 pi times the square root of 3. And that is what I got for the position of the particle at t equals 4.
So that was question number 6.